Well, today I am doing some soldering. This is a sort of what is it? A Mega 2560. That's what the board's called. It is a shield. I'm going to use the fingers there. It's a shield. I've designed this badly. It's not perfect. However, I'll explain not really why, but that it's not really my problem. So this, do you remember the high altitude balloon project that I was doing with some students at the university? Well, they've sorted out their package, the thing that's going to go inside the balloon to record their data and stuff. We've sorted out separately the tracking, how we're going to find it, but this is just what they want to send up in the payload. And so they've done it, and it is here. It's all like breadboarded up because they don't really make circuit boards or design them, so or at least not very much. So this is it all in a breadboard in a little cardboard box. This is the power we're going to be using, these lithium ion cells. So I believe we should be fine with those, hopefully. They're going to be charged up and then put into the package before it launches. So it should be relatively easy. But what I've done is to make our lives a lot easier. I've figured out all this breadboard stuff and put it onto this board. Now, the problem with this is they sort of printed or routed this not routed, what do I mean? I don't know, it's a machine and it comes along and cuts away the copper, whatever that's called. Etched, I guess, in a way. But they did this, but I sort of forgot, because I'm so used to getting boards printed elsewhere and in proper fab houses, that it's not going to be through-hole plated. So the little vias and stuff that I've got here, I'm going to have to solder through myself. And in fact, because I've done it double-sided, and I'm using little header pins on these sections, let's say it's this way around. I can't remember which way around this goes, but let's say it's this way around. That pin there is not going to be connected. So what I'm going to have to do, unfortunately, is figure out a way of going from that pin to this pin. I'm going to have to use wire instead, which is frustrating, and it won't make it as nice as it could have been, but it's certainly better than having it on a breadboard. Now all the components, so if I just pull one out, a lot of the components are small modules like that, which is a little micro SD writer. So this is going to be logging everything. So that is probably this one here because of the number of pins. That's not going to get soldered on top of the board, mainly because all of the stuff is going to be sandwiched up against the side of the polystyrene box that it's going to sit in. So this is going to come off on wires, probably those little Dupont cables, and have female Dupont go onto there and male go onto here and soldered on. And then this will separately get bodge taped to the side of the package. Now, bear in mind, this is the student's very first high altitude balloon project. So lots of things here are a learning process. Same for me as well. So I don't particularly know what I'm doing when it comes to this kind of thing. I've read up stuff on the internet, as you do. I mean, that's sort of a given, but there are always things that you don't think of or that catch you out. So if you see anything here that you don't think's right, don't keep it to yourself, but don't shout at me for it either, because it's really a student-led project. So I'm just assisting. But I'm going to be soldering this up today for them. They're on a holiday at the moment. It's like the break. So I'm going to be sorting this out because we're launching on the 23rd of June, hopefully. So not very far away. And it needs to get done. We need to sort our checklist out ready to go. So I'm going to solder this up and we'll see what it looks like. So I'm taking everything off this breadboard for now. So we'll take all the components out and we'll put them back eventually, but it will get rid of all of the little wires and stuff that we've got floating all over the place, so it'll be a lot nicer, hopefully. And then we've got our shield, so it goes this way round. We've got some pins already in there. I see, okay. So what is going on here? So I'm going to cut a few of these headers and I'm going to run them along here. So how many do I need there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And I don't need to do them all. There's a row that isn't populated, so I don't have to worry about those. Is that actually going to align? Hopefully. What I did to get this board done is I took the original design, the Mega, and I removed all the components, and I just used the outline. And I sort of made a mistake because on the board it has a cutout area, or rather no copper fill area, over the top of that USB, and I didn't pay attention to it. So I just left it, and it was meant to be a cutout, but they don't do that as standard. So let's see if we can't get these lining up. Right, that should cover it for the pins. Now we just need to make sure it lines up. They're going to need a little bit of encouragement. There we go. All of them line up now. So I just solder all of these pins and then it should become a shield. You can see that it's sitting nicely on the board there. And hopefully we're not touching this USB, but if we are, we can just pop a little bit of electrical tape on there, I think, to sort that out. Okay, let's get soldering. Now with boards like this where the copper's been exposed for a long time, it's not treated or plated, it's a good idea just to get a bit of flux on there so the solder will flow a bit more easily. So I'm just going to coat that and I think we'll refocus. Then after we've done this, we'll figure out where on the other side of the board we need to ping some wires around. It's okay because we can sort of feed them across this way and underneath, and that should be all right. But next time I think I'll either send this away when I've got some more time and we'll do it again. But for this little balloon launch, for the very first one, it doesn't need to be perfect, does it? There's always things to learn from, and the student team can learn from it. So they're actually working quite well. The large blobs of solder that have overflowed a little bit there, they're ground ones, so it's going to flow over that copper. There's nothing I can really do about it. Because again, this kind of board doesn't have any solder mask, so it is very important that you don't go outside of the pin area. So they are routed out, so there's like a channel that's routed around, but you've got to make sure not to go over that because it's going to ground out whatever goes over. I think the flux has evaporated there, so I'm just going to put a bit more on. I'm going to be quite liberal with the flux actually, because I know this kind of board, I've used it before. I've asked them to print me things in the past, and what you really need to do is make sure that nothing goes on the outside, because it absolutely ruins a design. Certainly with a complex board like a Mega, when you definitely don't want to ground out any of these I/O pins when you don't need to, so it is difficult. All right, have we done all of those? They look all done to me. Okay, then we've got some up here. Again, more flux, I think. Can't go wrong with having extra flux. Well, maybe you can, maybe there is a reason why you wouldn't, but I do not know what it is. So I'm really looking forward to this balloon launch. I've never done one personally, so it will be fun, but it is absolutely a student project. So I'm looking forward to it for their sake. And I really want to see the footage that comes back, because they're setting up a GoPro with it that's going to be recording for a long time. I think I might lend them my 128 gig SD card to do it, but I think we might be okay with the 32 one that they've already got. It's going up with some tracking stuff. So we're using Spot Trace, which is a very popular kind of tracking module. What it does, it reports every 5 minutes where it is. I'm also putting on, this is sort of extra to their stuff. So they're monitoring temperature, they're going to monitor the GPS location, they're going to monitor altitude and humidity, I think, and the battery voltage as it goes up. And I can't remember if they're doing it external temperature or internal. I think they'll do both. But I'm setting up one of these, which is an SI something something something, but it is, what is that? HC12, it's upside down. An HC12, which is a little wireless transmitter receiver. I've paired it up with another one. So this is just so when we're sort of close, I can get a GPS signal very quickly. It also sends out serial data. So they've programmed this board up to send out serial data of the status of the board. So it's got battery voltage, which is important because we need to know. I've gone over the pad there. I'm just gonna have to wick that up. Yeah, it's important for when we're about to launch the balloon that we know the battery voltage, we know I'm gonna have to get a bit closer. There we go, that sorted that out. Yeah, it's important we know the battery voltage, we know that it's recording data, receiving GPS data before we launch. So we have to make sure that's all correct before going, and it'll also tell us if the SD card is behaving and writing. So good to have a little bit of wireless telemetry, although you don't necessarily need it. It's we're still going to find the thing with this GPS locator, which is going to be in this a little gyroscopic ball, so that it's always facing like upwards, which is sort of ideal for a GPS. I mean, most of the time you can get a GPS signal horizontal or whatever, but upwards is always better. So that's what's happening. So we've got some more left to do here. I must have missed when we went around the first time. And I'm really looking forward to it. We're going to have like a little chase car. So we'll launch it on the day, and there's a website you can use. I can't remember what it's called now. But it will allow you to predict the path of the balloon, which would be great. And I'm going to take that little tablet with me, and I can plug in. That's what, do you remember when I showed you that little tablet? I showed you some GPS data, and then I had to blur it out because I realized that it showed all of my GPS data. I thought I didn't think it did. I didn't look at it frame by frame, but it turns out it did. But yeah, that's what that is. I was just testing out that we'll get the data coming in. So I'll take the little tablet with me so we can have it on the move, and I think it should be fun. Right, have I got every pin there? Let's just make sure before I move on to the next stage. They all look fairly well soldered. I think what I'll do, where's my multimeter? Somewhere around here. Let's just check for some continuity between the pins and ground. I don't want there to be any continuity between those I/O pins and ground, so I'll just plug in the multimeter and we'll find out. This is the Vici meter, and it's quite nice. I mean, it's fairly accurate, or at least it seems accurate. It's certainly not far off my other multimeter, which is something that I can't remember. But the continuity test, it might be more to do with the probes rather than the meter, but the continuity test is a little funny. So just have to make sure. Oh yeah, another thing with this, my grounds might not necessarily connect everywhere, so I wanted to check that they will. So, because there's no through hole, so this ground isn't maybe not connected to the other side of the board. In fact, it isn't, so I'm going to have to connect it. But there's a capacitor across here, or there will be, so I'll just solder it both sides and that should sort me out. Anyway, I wanted to check continuity. No continuity there. That should have continuity, so should that. I'm sort of getting a little continuity there. Just scratch the surface a little bit and then, no continuity, that's fine. None there, none there, none there, none there, none there, none there, none there. Right, that one has continuity. We'll find out in a second if that is actually a ground pin. None there. None there, none there, none there, none there, none there. So, which pin was it? The second one in? That one there has ground continuity. It doesn't appear to have gone out of the thing, but it could just be, it is a ground pin. I'm not sure. I think it is a ground pin actually. We'll come back to it. Do I want to take this off now? Yeah, I do, don't I? Let's take the 3D printed thingy off and take off the shield. There we go. So it is a ground pin, that's all right. That is good news. So there we go. So here are the wires that I need to sort out now. So we've got 2 tracks, 3... Okay, so we've got 3 tracks on the bottom side of the board that I need to worry about. And that's these 2 here, which need to connect to pins on this side, and this one here, which needs to connect to that pin. So that is... Oh, heaven knows, which one's that? Oh, no, it's this way around. So that's pin 8, it appears. No, it's not, is it? Pin 7. Okay. The other reason this is quite a nice board to use, this Mega, is it's got a fairly beefy regulator on it, and it can provide quite a lot of power. However, we're providing power externally, and we're powering the board through here. So our power is going to come in over here. We've got 2 power connections. Not sure which one I'm going to use, and we might actually break off power to power something else inside the little enclosure. So we've got power here, several decoupling capacitors, and it should be good. So I'm going to start putting some wires on here. I may just use these Dupont wires and just solder them straight onto the board like that. And then these modules can just sort of nip on the end, I think. So I'll get started on that and I'll come back to you when it's done. Right, almost all done, as far as it's actually going to go today, because the rest of the stuff is either power or it is the temperature sensors, and they'll be connected to some longer wire. So they'll be, I don't know if it's going to be inside or outside the capsule. That's up to the students to decide, I think. But they're using TMP3736GZ, I think that's what it is. So they can read negative temperatures. So it might be that they're putting them outside. So anyway, this is what's happened. It's a bit rubbish. I mean, this is the problem when you don't have through hole plating. So I've had to route some wires around the board. You'll see on the back here that we've got them sort of soldered to the track there and then coming around. But it's okay. It's much more physically sound than being in a breadboard. So that's really the only aim, is just to remove the breadboard from the equation. So let's see if I've got it lined up correctly. I have. So it just slots in like that. The wires come through the little hole at the bottom there. I know it's not really focused and you can't see it, but that is the whole idea. This is going to be the battery monitoring terminal. So we'll go straight from the batteries into here through this resistor. Can't remember what that value is now. It was probably appropriate, I'm not sure, to read the battery voltage. And so everything else is pretty much there. So I'm going to give it a test next week with the students, hopefully. And if they're happy, then we'll go with this sort of board layout, or we'll do it again. I mean, it doesn't really matter. We can do as many as they like. So I'll design this up for them. Some of the students come from, you know, loads of different courses, textiles, architecture, business. It's a club, an electronics club. So it's not actually just for electronics students, which is why some of them won't know how to do this. But they learn as part of this club how to do things. So yeah, looks like a success. I will test it, and then probably you won't find out about it until the launch, and I'll do a little video then of the launch itself. But I hope everything seems to test out well with the continuity tester to make sure I'm not touching ground anywhere where I shouldn't be. But yeah, some little ugly solder blobs around here where I've tried to solder a ground and it didn't heat up the pin very well, but it did heat up the copper around there, so it all flowed over there. It doesn't really matter. It would be, that kind of thing would be avoided if it had a solder mask, but because it doesn't, then that's really the issue. So this will be bodge taped together anyway. So these are physical connections soldered on. They're pretty stiff, but there'll be maybe hot glue, possibly. Hopefully it won't melt the solder. I'll do a little test first. Hot glued on, and then put into the little polystyrene enclosure and sent off into the edge of space. Anyway, it's only a little quick thing to show you this. It's not really my work. It's the students. So just putting it together for them in a really terrible fashion. I'm sure they'll be well pleased. I did 3D print them a little stand thing for the Mega, so that when they're working on it on benches or anything, if they've got little stray things like this, these are resistor leads, they don't really touch the bottom. They sort of sit on top of the 3D printed thing. Anyway, I'll speak to you all soon.